Hello, sir. This is Omkar Kulkarni from B Division, roll number 132. Basically, my project is given an image to this software, to my software. It can predict or it can detect the land type, whether it is agricultural, residential, desert, all those kinds of things. Uh, I have opened the NASA Worldview website. NASA satellites basically capture the world, Earth from different angles. I was willing to use this dataset for that type, but this image size is huge, like 800 GB to 1000 GB. So I used this UC Merced dataset. Basically, University of California students took this NASA images, uh, satellite images, and divided into smaller sizes. They also have 21 categories like agricultural, airplane. You can see here. This is my dataset. So I will explain the flow of my project. I used a pre-trained deep convolutional neural network named Inception V3. With the aid of transfer learning, with the concept of transfer learning, I trained my model on this UC Merced Land dataset. After the model learned on the dataset, I did the process of feature extraction. Basically, there are many layers in the system architecture of this deep convolutional neural network. From those dense layers, I took one of the layers and extracted features from the images. So images were basically given to the model, and features from those images were extracted and saved to an Excel file. I also those features were combined with GLCM features. GLCM is a concept which also gives features from the images. I combined both the features in an Excel file and gave them to Weka, wherein some ML algorithms were run, and it correctly predicted uh, and classified the type of land. I'll come to code. I ran the code on Google Colab. Herein, first I mounted the dataset from my drive. Then did some basic pre-processing. After that, here I loaded my DCNN model. As I said, unfried some of the layers before global average pooling layer. To be precise, one layer before global average pooling layer, and trained that layer for 10 epochs. Here it is mentioned, and for each epoch, I calculated the training loss and training accuracy. After 10th epoch, the training accuracy was 98%. So model is well trained. Furthermore, I iterated through each and every image, and as I said earlier, extracted features for each of the image, and after some normalization and all those kind of things, I saved it to a CSV file. This CSV file, as you can see here, sir, this is for 1000 images, and one each image has 1024 features. Correct. This Excel file is given as input to Weka, wherein different machine learning algorithms like LMT, random forest, random tree, J48 were run. And for example, if I can load random forest, the classification accuracy is 97.3%. So basically, out of 1000 images, 973 images were correctly predicted. Here is the confusion matrix. So basically, 99 images were correctly classified agricultural. Two of them were not. So basically, all those 10 categories confusion matrix is given here. The conclusion of my project is basically government agencies like NASA, ISRO, or Government of India, these authorities need to uh, use this kind of project to see how much deforestation is done, how much or for urban planning purposes. So my project can be extrapolated to use on this level, like they can use this for urban planning, how much deforestation is done, where are like rain is more, rain is less. This can be done. My project basically does this on a smaller scale. Thank you.